Good morning, modern college algebra students. Hey, we're in 1 week in with our class, and I'm excited. We're going to go ahead and get 6.3 done today. I've been trying to communicate with you guys a little bit on just making sure, we need to get I'd like to have 6.3 done by the time you come in on Tuesday morning on the 2nd. If you have any questions or if you're struggling with getting this done, you need to let me know. But we need to keep moving or we'll run out of time towards the end. Hey, I just thought I'd go ahead and start with a review from 6.1. It's actually not my number 10. Yours will look just a little different, but I imagine they'll have a negative in here because I want to talk about what happens and when we substitute that value in and we're squaring it, making sure you get your signs right. Now, the very first thing you notice, we have a -5 out in front. That's going to be my coefficient. And so I'm going to have a -5. Now, this is saying that I'm going to times it by x squared. Well, x in this case is going to be equal to a -6. So that means I'm going to substitute x in there for -6 and for x. So I'll have -6 expression squared minus 3 times -6 and minus 2. Now, the next thing we will do is our exponents, and so we're going to take then a -6 times a -6, and that's where this is going to change to a positive. So I'm going to go ahead, I know that's 36, but then I'm going to multiply it times a -5. So I'm just going to go ahead and go 36 times 5, but I know it's going to be a negative because I have -6 squared makes it positive. But then times a -5 makes it negative again. So I have a -180. Then I'm going to go ahead and go a -3 times a -6 gives me a positive 18. And then I'm going to have -2. Well, in this case, I'm going to go ahead and just go a -180, then plus 18, and then -2 gives me then an answer of a -164. I don't know why I keep writing these guys without my 100 digits, so my brain's thinking it may be at the end of the day. Today we're going to go ahead and kind of work on applications of linear equations. Now, if you remember before, that what we just did was just an expression. So if I look at just this part, which is the -5x squared minus 3x minus 2, there's no equal sign, and so therefore it is just an expression. And the only way we can kind of simplify it is if we are given what we think what x could be. And remember, in this case, I could substitute a lot of different values back in and get a different answer for x. So in this case, when I have an equation, though, that actually says that I'm going to actually solve it, and I'm going to end up with an answer, like one single answer, or maybe a combination if we have a quadratic. A couple of things that I want you to do. They do talk about the strategies that they would like us to use for solving word problems. I think it is so important for you to read the problem carefully. And then we're going to start working on some ACT reviews things. And a lot of times I believe that your ACT math section is actually a critical reading section as well. Because a lot of times they do try and trick you up with your answers and try and kind of maybe give you an answer that if you didn't quite solve it, and we'll talk about why it's important to make sure you read the problem carefully. A lot of times, especially if I'm working on a problem, I'm going to break it down. I'm going to write down I'm going to underline some key parts. That also helps me when I'm doing these problems. And at number 2, it says, if necessary, write the equation for any other unknown quantities in the problem in the terms of x. Now, again, they suggest x, but remember, we can use any variable. They just, sometimes x is just kind of universal. Write an equation that models the verbal conditions of the problem and the problem's questions, and then solve the problem, and then they also suggest that we check. And again, very important. I would really recommend that, especially on tests and that sort of thing, that just putting it back in just makes it show that you've got the right answer. So the first couple of terms, when I work at if I'm going to add my unknown with something, a phrase that would be a sum. Sum is the definition is the answer to an addition problem. And anytime I have the word more than, that means I'm going to add or increase by. Subtraction would be then minus, decreased by, subtracted from, difference between, less than. Now I'm going to talk a little bit about whenever I see the word than, then if I said 5 is less than x, then I would write that as x minus 5. It's like I switched the order. So when you see the word than, make sure in terms of changing that order. More than can add numbers in any order, and it doesn't really matter as much, but it's the same principle. If I had 5 as more than x, typically the best way to say it would be x plus 5. But again, it's not as crucial as it is in the negative when it's subtraction because of the fact that we're subtracting. The multiplication, a couple of words that you will need to kind of take note of is product is the answer to a multiplication problem. Percent of a number means, again, that's your multiplying. Multiplied by or twice. Division, quotient is the answer to a division problem. The reciprocal means that we flip, for instance, the reciprocal of 3 over 4 is 4 over 3. I'll put that there so we know with this reciprocal of 3/4 is 4 over 3 where we flip them. And so we're going to start off with some of the problems that we have today. So the first one says when 2 times a number, so I'm going to go 2 times a number, is decreased by 4. So there's your answer. The result is, so I usually try and underline or circle the is, 26. And so this is pretty straightforward. If we let x equal the number, then I'm going to take 2 times that number. So if I have 2 times x, then I'm going to is decreased by 4. So in other words, I'm going to subtract 4 from it. So that means I'm subtracting. The result is usually will always mean equals. Equals then 26. And then all I need to do is go ahead and solve the equation. So I'm going to add 4 to both sides. Excuse me. 26 plus 4 would be 30. So I have 2x is equal to 30, and then divide both sides by 2, so x 15. Now, to check, then you would go ahead and substitute it back into your original equation. And so I would take then 2 times 15 minus 4. Try and get my parentheses in the right spot. Is going to have to equal 26. In this case, 2 times 15 would be 30, minus 4 is 26, so that checks out. When I have the next one, I have 80% of a number is added to the number. The result is 252. So I'm going to start, when I have the word of is also another word that kind of indicates the multiplication. And then I'm going to change my 80%. 80% is not going to be written, I don't want to use 80, but I want to change it into the decimal equivalent of 80%, which would be 0.8. Again, my x, I'm going to let x equal the number. So I'm going to go 80% of a number, so that's 80.8 times x. I have the word is added to the number, so that means I'm going to add that number again, so I add the x. The result is 252. Now notice I did have another is, but in this case they're comparing these two, and so that doesn't necessarily indicate it's going to be an equal sign, even though a lot of times it does, but it doesn't always. So then my next step would be to go ahead and combine my x's, and so remember this is actually the same as 1. So 1x plus 0.8x is 1.8x is equal to 252. And then to solve, I'm going to go ahead and divide by 1.8 on both sides. So my answer will be then 252 divided by 1.8, and so my answer for x is going to equal 140. One number exceeds another number by 26, and that sum of the numbers is 58. So here's my is, and so it's what it equals to. So that means I'm going to add the sum. I'm adding these two. So one number exceeds a number by 26. So if x is going to equal my first number, I know my second number exceeds it by 26, means it's going to be x plus 26 is going to be the second number. Now, if I'm going to take the sum of these two numbers, then I'm going to end up with x plus 26, and that result is going to be 56. And so, 8, sorry, not 56, 58, sorry. So then I'm going to go ahead and subtract both sides from, or I'm going to add the x's together, so I have x plus x, which is going to be then 2x. But I'm going to subtract 26 from both sides in the equation. And so 58 minus 26 is 32. I'm having a hard time with my numbers today. Mrs. Bartlett would be so disappointed. Divide both sides by 2, and so x is going to equal then 16. Okay. Then you can also go ahead and check. Does 16, and then if I have 16 plus 26, it would also be then 42. Is 16 plus 42 58? And it is. The next problem we have, it says a bar graph shows the average yearly earnings in the United States by educational attainment. So in this case, if I have someone who just has a high school diploma, this is going to be the average full earnings of a full-time worker. And then it would be then in female would be the darker one and male would be the lighter one. And then it goes all the way up to a master's degree. So in this case, it would be, again, then the female on this side and the male on this side. And so the average salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of the man with a master's degree exceeds that of a man with an associate's degree by $45,000. Combine the three men with these degrees earn $214,000. Find the average yearly salary of the men at each of these levels. Now, first of all, let's go ahead and let X represent then the average salary of a man with an associate's degree. And the reason I'm picking this is that if you notice it says the average man of a bachelor's degree exceeds that with an associate's degree by $25,000. And that with a master's degree exceeds that with an associate's degree again by $45,000. So what I'm going to do is I'm going to actually start by writing it in terms of X. So X, if I start off with X letting it be the associate's degree, then I know that I can go ahead and, since they're comparing the associates with that of the bachelor's and then with the master's, I can write then my bachelor's ELORS in terms of X. So the average yearly salary of the man with a bachelor's degree exceeds that with an associate's degree by $25,000. So in other words, the bachelor's degree, if the X is going to be the associates, it would be X plus 25. And the same thing will go with the master's degree. It says that it exceeds a man exceeds that with an associate's degree by $45,000. In other words, the master's degree is going to be $45,000 higher than the associate's degree, indicating it you could go for X plus 45. Now it says the next one, find the average yearly salary of the men in these three educational combine the three men each with each of these degrees earn $214,000. So if I were to add all of these degrees, so if I have X plus 25, and I don't have to put parentheses in there, I'm just kind of showing you that I'm taking the associates, the masters, and the bachelor's and the master's and adding them together. Okay, so if I have the 3 degrees, then that's going to equal then the $214,000. And so on this one, I'm going to go ahead and solve then for X. So I have 1, 2, 3X. That's a 45 and not just a 4. Then I have then plus then 25 plus 45, which is 70, is going to equal 214. I'll subtract the 70 from both sides, and so I end up with 214. Oops, I didn't get the 2. 214 minus 70 is 144, so 3x is going to equal 144, and then I'm going to divide both sides by 3. So 144 divided by 3 is going to be then 48, so x is going to equal 48,000. Now, they really didn't ask for just this would be the associate's degree, so I know that this one is going to be 48,000. That means the bachelor's has to be that plus 25. So plus 25, that's going to be $73,000. And the last one would be then the 48 originally, which was the associate's, plus 45. And that's going to be then 93,000. So in this case, that would be the 3 levels of the education and what they would end up with. The next one, it says the average yearly salary of a construction worker is $11,000 less than 3 times that of a fast food worker. Combined, the fast food worker and the construction worker earned $65,000. So again, I'm going to have to choose my variable on what x is going to equal. And if you notice, they're going to say that the construction worker is going to be comparing it to the fast food worker. So what I would like to do is let x represent the fast food worker. And then it makes it fairly easy to come up with a good worker. The construction worker. Okay, so construction is 11,000 less than. Now keep in word, there's your less than, so we're going to move the order around. 3 times that of the fast food worker. But if my fast food worker is just going to be x, then I'm going to have 3 times x. It's going to go first. Then I'm going to subtract then the 11,000. And it says the combined earned salary is $65,000. So if I have x plus 3x minus 11, that should equal the $65,000. Now keep in mind, I'm going to go ahead and keep it just 65, knowing that I'm working on thousands. So I'm going to finish it up. I have x plus 3x is 4x minus 11 is equal to 65. Move my 11 to the other side. Whoops, plus 11. And so 4x is going to equal 76. And then x is going to equal then 19. So 76 divided by 4, I guess I could have showed you 76 divided by 4 is going to be 19. So that's 19,000. Okay, the next part, it says we need to also find the construction worker. So if the construction worker is going to be 3 times the 19,000 minus 11, so 3 times, oops, I hit divided by, clear, 3 times the 19 minus 11, hey, let's go minus 10 again since I only hit 1 in there. How about 45? So that means my other worker is going to be then 45,000. 46 is what? Okay, let me look. 3 times 19 minus 11 is 46. Did I say that? 1,000. And again, I'll put... The next one, you are choosing between 2 texting plans. Okay, so we have a plan A with a monthly fee of $20 with a charge of $0.05 per text, and plan B, which is going to be a monthly charge of $5.10 per text. Both plans include a photo and video text. How many text messages will cost for the 2 two plans to be the same. So let's just start with this. I'm going to go ahead and go plan A. And I'm going to also let X equal the number of text messages. So in this case, if I have a monthly fee of $20 with a charge of 0.05 per text, that means I'm going to have to multiply the 5 cents, the 0.05, times X. But then I'm going to have a flat fee of $20, so it's going to be plus 20. Plan B will be then a monthly fee of $5, but you're going to be charged 10 cents per text. So it would be 0.10 times X plus $5. And what you want to do is you want to find out when these are going to equal. So 0.05X plus 20 has to equal 0.10X plus 5, and then when we solve for X, that'll tell me when both plans will be the same. Now, I can go and keep it in the 0.05, or I can also, I'm going to show you, remember, we can multiply everything by the 2 decimal places. That would get rid of all of our decimals. So I'm going to go ahead and demonstrate that. So I'm going to move the decimal place over 2 places here and leave it with 5x. But I have to go, don't forget, I have to go 2,000 then, because I'm going to move my decimal place over 2 places. This one would be then 10x, and then I'm going to move my decimal place over 2 places, plus 500. And then I want to solve. So let's move the 5x to the other side. So 10x minus 5x is 5x. But then I'm also going to have to move my 500 to the other side as well. So 2,000 minus 500 is 1,500. And then, so my answer then will be then 1,500 divided by 5. And so I'd have to have about 300 texts for the plans to equal. Okay. The next one, it says your local computer store is having a terrific sale on digital cameras. After a 40% reduction in price, your purchase of your digital camera is $276. What is the camera's price before the reduction? So in this case, you're going to go ahead, we're still going to allow it to X to equal what we're looking for. It's going to be the price. So let me do a $sign before reduction. Okay. Then the next one, if I'm going to notice that after a 40% price reduction, so they're going to take that number, the amount. So let's just pretend for a second it happened to be 100 to make it real easy. You're going to take that $100 for the camera, you're going to take it times 40%. But remember, that's not the part that's the reduction. So remember, we had to start off with the $100 and subtract that reduction away. So in order for me to write my equation, I need to start off with the price it was before the reduction minus then the 0.4 or 40 times X. And then that's going to tell me that my price then would be then the $276. So in this case, I would have then the 0.6 X would equal the 276. And so my answer for my original price, so 276 divided by 0.6 gives me $460. Now the next one we're going to work on motion speed. So we need to know a little bit about distance is equal to rate times time. And so I know that we're really probably very familiar, since all of you are driving, with miles per hour. And so I know that if I were to drive in my car 60 miles per hour and I would go 30 miles, then I would take for 30 minutes, then I would just take I would take 60 times 30, and I would end up going 180 miles for that time. Now, today we're going to talk a little bit about what we do with the current. And so if you notice, the rate is going to be the speed plus or minus the current. So imagine you're in a boat and you're going along a river. So the river is flowing and it's flowing in this direction. If I'm going against the current, that means I'm going to go, the speed of the water will be a minus than the speed that I'm traveling. If I'm going to go with it, then means that my current will be an addition on that. So again, going with the current means you're going to have your rate is going to be the speed plus the current. Going against will be the speed minus the current. So we have a problem that we're going to work on. It says a commercial jet has been instructed to climb from its present altitude of 7,000 feet to a cruising altitude of 22,000 feet. The plane ascends at a rate of 1,500 feet per minute. How long will it take to reach that cruising altitude? So in other words, it's going to gain. It's going to look a little bit like this, where we're starting here, and it's going to speed up. It's going up. Starting where this is going to be 7,000. And then once it gets up to this part, it's going to then be going 1,500 feet per minute. And so my equation is going to look, it says for when the plane is going to go from 7,000 up to 15, what did I say? Oh, why did I put 1,500? Oh, I'm sorry, I put he's going to add a speed. This is your speed. Your rate is going to equal 1,500 miles per hour. He's actually going to go to a height, remember, of the 22,000 feet. Start at 7,000 feet. We're going to go 22,000 feet. So we know that we're in this case, this distance, that how much it's going to go up will be then the difference of 22,000 minus the 7,000. So in other words, his distance that he's going to climb will be then 15,000 feet. Now, the equation that models this would be that your rate, which is going to be also the 1,500 feet per second, and then we're going to go times our time, because they're asking how long will it take to reach that cruising out. So they're looking for the time is going to equal then the 15,000 feet. Now, in order for us to solve, then we're just going to simply divide both sides by 1,500 feet per second. Now, when I do that, remember, it's also multiplying it times its reciprocal, because what I want to do is I want to really look and analyze what happens to the units. So I start off with 15,000 feet, and if I divide both sides by 1,500 feet per second, that's the same as multiplying it by 1,500 seconds per feet. And what will happen, whoops, sorry, I need to go dividing it. And then what will happen, these two values will cancel out, and so will my feet, and I'm left with just the seconds. So 15,000 divided by 1,500 is going to be 10, and then my units left would be then seconds. So my time is going to be that. The last one, Jen has a motorboat, so that travels at a speed of 13 miles per hour in still water. So let me go the boat. The rate, let me just go the boat. Boat is going to equal then 13 miles per hour. Okay, the river flows at a speed of 2 miles per hour. So let me go river. Okay, how long will it take Jen to travel 12 miles an hour upstream? So let's go ahead and do a picture. So we have the bank of a river, and our river is flowing in this direction. And then we're going to have a boat. We're going to, in this case, how long will it gin to travel upstream? If I'm going upstream, that means I'm going to go against the current. So I've got my boat here, and it's going to go this direction. And it's going to end up going just 12 miles. So my distance is going to be equal to 12. So I have then a rate, which is going to be then the 13 miles per hour. Going upstream, I'm going to have to subtract then the 2 miles per hour. But then I'm going to multiply all of that times my time, and it's going to equal then 12 miles. So 13 miles per hour minus 2 miles per mile per hour would be 11 miles per hour. And then I have it times the time is equal to 12 miles. Now if I divide both sides by 11 miles per hour, remember, let me just 11, maybe if I write it this way, miles over hour is the same as per hour. That means I'm going to flip this, so that means the hours are going to be on the top, and on the bottom I'm going to have 11 miles. Notice those will cancel out, and so I'm left with 12 over 11 hours would equal my time. So in other words, it's a little bit more than 1 hour. And so in this case, we're going to do a few more of the rate problems. You will see a rate problem on your test that we have, so just keep in mind when you're working those when you're in your homework, and then we'll continue doing a few more of them as we go along. Have a great day.